This conference will now be recorded.
Good morning, everyone, and welcome to this webinar about static analysis. My name is Joachim, and I work at Nova Solution in Malmö. I work in sales, and together with me today I have Mikael Gustafsson, who's working technically with a tool called CodeSonar, we will show today. I see someone is calling in from Denmark. Then you should talk to Henrik, my colleague in Denmark. And some of you are calling in from Finland, so you can contact Marco if you have any questions after this meeting. This webinar will be recorded. We will hopefully not consume longer than 45 minutes, and you will get a recording of this, of course, and we have questions session afterwards, so you can supply your questions via the chat and so on. So today I will give you a short overview of static analysis, and then we will show you two demos today. One more like an introduction to CodeSonar, so you understand what CodeSonar is, and one specific for libraries. That is how CodeSonar is using binary libraries. So I will start a little bit with what is static analysis. Yes, basically you can say that it's checking a program without actually executing it. So what can you do with static analysis? Well, you can validate the coding standards, and that is what CPP check does, lint, PC-lint, and so on. But you can also verify how the code will behave. So you can detect undefined behavior, API misuse, and other suspicious behavior like dead code and so on. And static analysis can be quite expensive in terms of computer usage, but it's very affordable man-wise because you get it all presented to you, what the tool detects. And you also get a better coverage than dynamic testing, because when you are testing dynamically, you need to drive your system with a certain flow or path, but with static analysis you don't need any test case and so on. You just assume different parts of code, how it can run. So not all static tools are the same. So as I mentioned, you have this PC-lint, CPP check, and so on. That is more a low-level tool, and then we have a more verification tool. It's usually used on hardware and this kind of thing, but it's not very easy to scale. And then we have some advanced code analysis, and that is what CodeSonar does, that we're going to talk about today. I will just mute Mikael, my colleague here. He's typing, so I will mute you, Mikael. So all static tools, they give some indication. So when you do a static analysis, you either get a positive indication or you get a negative, that is nothing. And this positive indication, when you issue some kind of warning, could be either true positive or a false positive. And false positive means that it's not correctly identified. It could be that this is taken care of by some other part of the system in a library, or you don't have all the information, or it could most often it's not a incorrect appointment or identification, but the tool doesn't have all the information. So that's why we having this webinar today, to just show some technique that you can get less false positives. But all tools get true positives and false positives. So why should you use static analysis? Well, once you can compile your code, you can start testing it in terms of static analysis. So you can find early errors very early in the process, and then it will go through some code that might be difficult to write test cases of, and it's also very efficient to use with together with code reviews. So this is one example, and this customer, they deployed some software, and afterwards they crashed immediately, and the takeaway is that static analysis is saving time, but you need to deploy it into your developing process. So CodeSonar, what is that, and who is Grammatech? We have been working with a company called Grammatech, that is a US-based company, for more than 2012, I think we started to work with them, and they have been existed over 35 years doing static analysis. And the flagship they have is the CodeSonar tool, and that is the deepest static analysis for C and C++. And it has a very user-friendly interface, and it's highly customizable. So we will show that, or Mikkel will show that a little bit later on. So what do they offer? They offer, and know-how also offering, of course, because we are partnered to Grammatech. We offer CodeSonar for source, and that is static analysis for source code only. And we offer CodeSonar for libraries, and that is actually an add-on to the source that also include binary libraries, as we will show a little bit later on today. There is also a functional safety kit to CodeSonar if you're working with functional safety related development. So you can buy a certificate, you can have some assessment report and tools, safety manual, and so on. And the last thing is a new solution, CodeSonar it's called. So what that solution do is that you scan your binary, and from a binary you create a software bill of materials. And when you know which components that is included in your binary, you will list all the known vulnerabilities in that, or in these components. And this is very useful when you use third-party, open source, and things that you don't have full control of in terms of the source code. Some customers of CodeSonar, it's mainly technical customers using C and and how does CodeSonar work? Well, you parse the code into a model, and on that model you run different algorithms to find potential problems, and then you try to explain this or show to the engineers why CodeSonar has found this problem. And basically you can see that you have your source code or your binaries, you parse that, you do different kind of analysis on that, race analysis or Tate analysis, and then you place everything in a database. And after that, after you have placed it in a database, you can, let's see what happened. You can view it either from a browser, a web browser, where you can explore and do reporting and do visualization and have dashboards and so on, or you can display the analysis result in an IDE like Eclipse or Visual Studio. So by CodeSonar, you will get better quality, improved security and safety, and easier compliance. So now I will turn over to you, Mikkel, to show CodeSonar, and then I get back to you later on.
Thank you. Can you hear me?
Yes.
Good. Thank you. Sorry about the typing.
Oh, no problem. So I made you presenter now.
Yeah, you can see my screen, I think.
Yes, yes.
Okay. So let's make a demo of CodeSonar. And here I've connected to my hub using my Chrome browser. And as Joachim mentioned, the hub is a server that contains the analysis result. And on the first page here, I can see some different projects that I've been working with. And I've created a project that I use for demo purposes. It's an open source project. It's called GNU-Chess. I downloaded and compiled, and also made some analysis with CodeSonar. And we can see it's a quite small project, only 12,000 lines of code. And if we click on it, we get to the latest analysis. And first off, we can see I got 83 warnings in this analysis. Now I've used only the default settings, and that means that not every checker has been turned on. I can compare that with the previous analysis. Here I turned on all checkers in this analysis, and I got 4,000 warnings. So almost one warning on every third line here. When I turn on all checkers, all MISRA checkers will be turned on, and this code is not written from MISRA, and that will generate lots of warnings. So we have this view, this list of all the warnings, and we can have a look at the different columns here to begin with. So first column here to the left is score. Score can be seen as a severity for warnings. It goes from 0 to 100. The higher the number is, the more severe CodeSonar think it is. And this is very useful, so you can decide which warnings to fix first. Next column is the ID. So every warning gets a unique ID number. And CodeSonar uses a fingerprint method to determine in the next analysis if this is the same warning or not. Even if a warning moves in the code, it will use this fingerprint method to determine this is the same warning, and we get the same ID number. And that's useful when we want to suppress a warning, so it will not be shown in the next analysis. When we have class, and it shows what kind of warning it is. And we got significance. It's a high-level indication of what kind of warning it is. We got reliability, security, and there's also redundancy and style. When we have file, line number, and procedure, we find the warning. And lastly, we have priority, state, finding, owner attributes. We set them ourselves, and I will get back to them shortly. This list view is configurable, so I can sort them with different columns. I can move them around. I can hide them. I can show different columns. But I can also make a chart. So here I made a quick chart of the different warnings in this analysis, and I can see that I got 15 tainted buffer accesses, the most common one here. And I can click that one and get a list of all these warnings. And it's followed by 9 null pointed references and so on. But in this demo, I'm going to show you a buffer overrun example. And in this analysis, I only have one. But to take a closer look at it, I click on it. So here we can start to have a look at the actual warning. So we can start off by looking in the manual if you don't know what the buffer overrun is. So every warning have a description in the manual, and here we have a summary. So we have a read or write of data after the end of an object in memory. I can see different categories that this warning is mapped to. So we use that in different MISRA warnings, AutoSAR, CWE, CERT-C, and so on. And often it comes with some small code examples also. Now, this is a very small example, but for this warning to occur, should a benchmark code be executed? So we have a traceback that we can follow, and CodeSonar helps us by describing what with different events in the code, how it sees what is happening. So this green arrow is one control flow information event, and these yellow triangles are important events on different lines here. So I can click on this and get to event 1. We are taking true branch, dest evaluates to false. Now I could click on the yellow triangle and get all the warnings on that line. Or I can just step to the next event. So event 2, S is passed to strlen function. Strlen function returns the length of a string pointed to by S. And so on. I can step down and CodeSonar explains how it sees everything that's happening. All the way down to a warning occurs. So CodeSonar is very good to giving you information what is happening. So it really explains. So to summarize this warning, this code was passed at the end of a buffer pointed to by new lock. New lock evaluates the malloc strlen s +1 on row 2209. I can make it a little bit more readable here. Some more help we have. We have a cross-reference here. So if I put my mouse over something, I will get information about that. So here I can see a new lock is a local variable. I can see the definition. I can see where I read from it and where I write to it. Do I put my mouse over something else to get information about that? So malloc is a function. I can also jump to the code. Now, this example, I think it's very good. It's a quite easy example. The problem is that the developer has put +1 outside the parentheses, and we get a buffer overrun because of that. But I really like this text comment from a developer. This doesn't have buffer overflow vulnerabilities because we always allocate enough space before appending. So the developer has been thinking correctly, but just not implementing it correctly. Had he done an analysis, he would have found this and fixed this in 5 minutes, no problem, before he checked in the code. Now this warning is also existing several releases later before it was fixed. Some more help we can get from CodeSonar. Perhaps you would like to see all the ways leading to this function that the warning can occur. So here we've got the different paths leading to this function, and we can check these paths. So the warning is detected on a red marked path. So it's working. And I can take a closer look at one path if I want to. So here I start in this function, in this cmd.c file, and I have a traceback I can follow all the way down over different functions and files. To the warning. And I mentioned some attributes earlier, and we can set them here. So we have a priority. We can set them as high, medium, low, or suppressed. If we suppress it, it will not be shown in this analysis or any later on. We can set the state, assign, fixed, invalid, later, new. There's a possibility to set up so that it automatically get all the new warnings that occur to have state new, then we can filter them out and just have a look at the new ones. Finding, is it a true positive or not? And we can also set an owner to a warning, so a correct person fixes it. And we can also add a note. For example, if we do a suppression, we should explain why we do suppress it. And these attributes will be saved in history here, so every changes we make to these attributes will also be shown in the history of the changes. So this was a very small example, but we can have a quick look at another example here. It's a little bit larger. And we can start off by jumping directly down to the warning location. And first we see that we have got 52 events that are leading to this warning. And if we read the summary, it says the resource was allocated at the util file line 129. And last reference was lost at book_make, line 202. The resource has not been freed, and that means we have a leak. So we have some dynamically allocated storage that has not been freed here, and that can lead to a potential reduced performance in the software. And in the same way here, you can see that we got the traceback that leads us over different files and functions. And we got our events in the code that we can follow. So CodeSonar explains the problem. Okay, what more do we have? We have more possibilities with CodeSonar to help us out. Here I got a GNU project, and we can see that I've made an analysis from version 5.05 up to 6.03. And we can have a look at, we can create some charts and tables. So I can very easily create my own graph. So now I'm interested to see the number of warnings, how they have developed during the different analysis. So like columns and different analysis, number of warnings, and I want to have stacks. So here I've easily created a graph over the trend, over different analysis of warnings. And we have a slight negative trend here between analysis 5.08 and 6.0. Of course, we would like to have a downward trend instead. But if we would take a look at the size of a different analysis, we could see that this is increasing a lot between the different versions also. But it can also be that we get some new people in working with a project. So it can be different reasons for this. So this can be useful to have a look at. We can also extract reports. We can get them in XML, HTML, or PDF format. We can take a quick look at the standard report here. We get a summary, we get a warning by class, warnings by file, warning instances, and some different metrics values. But we can also very easily create our own reports. Here we have created a report for MISRA C, for example. Now, this code is not really written for MISRA, but it contains some checkers that also is used in MISRA, so we should get some result here. Down a little bit here. So here we have rule 2.2 in MISRA, there shall be no dead code. And here we can see what warnings we have enabled to check for this in this analysis, and where different violations we got here. So quite easily to create your own reports also. And we can also extract some metrics. For example, the most common ones, different code information. And we can also look at cyclomatic complexity, for example. And we can also compare different analyses with each other to see what is new and what has disappeared in different analyses. And that is more or less what I'm going to show you in this standard demo.
Okay, thank you, Mikael.
So I will make you presenter again, Joachim.
Thank you. So the next part of this webinar is to talk a little bit about libraries. So what happens if you have components that you don't have the source code for? That could be that you have an object file from a vendor, or some other, for some reason you don't have the object code. Of course, the analysis does not know the logic of the library, and the analysis need to make some assumptions. And it usually gives some alerts that CodeSonar identifies some function, but they can't find the definitions of that. So when you use a binary library, you have some questions. Should you allocate the memory in your code, or is it deallocated and allocated in the libraries and so on? Should I free it and so on? One other thing is, can I create buffer overruns and so on by using an API? And of course, you can do that, and you will do that often. But CodeSonar can analyze libraries. So this is quite unique capability of CodeSonar. So what it does is that it ingest the libraries in source in object code, and you don't need to provide any debug information, or you can it can also be optimized code and so on. And this binary library is then added to the program model, and then it's analyzed in the context. So I will show you a small example. So here I have Jenkins just to build some CodeSonar analysis, and here I have a very small example, mylib. And as you can see, I have built it a couple of times, and I get some information about warnings and number of codes and so on, line of codes and so on. And here you can see the line of code is varying depending on if you include libraries or not. So I will open this analysis, and I can see that this is done by source code only. So in my case, I don't get any errors in this case, but I got some alert, some undefined function. So I will look at that, and it says that, okay, I have found something called foo that I don't recognize. And the solution or resolution for this is either you don't have the source code, so then you get the source code, or if you don't have a source code, you can create a library model to model the behavior of this component. Or, as I will show you, you can also use binary analysis to get some information. It could also this alert can also, if you don't have software that is included in the builds and so on. But basically, I would like to see what's this foo is coming from. Take a very long time. I have it on another machine, but hopefully, yes. So I can see that in this file, I have a call to foo, and that is defined in the lib.h, and it's in a library which I don't have a source code for. So what I can do with CodeSonar is I will do a new build here, but in this case, this is just some parameters I set in Jenkins to build. And the most important parameter here is that I have created is for libraries. And what I tell CodeSonar is to not only analyze the source code, I tell them also to analyze and include the object code. So I start this build and it starts to process. And here you can see it's processing the object code as well. So basically you have your source code and your object code, a library code in object, and then you pull that into the model, and then you run all the checkers on that. And of course, not all the checkers in CodeSonar can apply on a binary code, because there are checkers for styles and so on. That is not, of course, applicable on a library object code. But it detects buffer overruns, memory problems, and this kind of thing. So I will just wait until it's ready. I can open up here. I will also sign in here to get my views. And as you can see here, now I get a new warning in my source code when I included the library. And it will say that I will get a buffer overrun if I use the library the way I do it right now. And this is this faux. And you can also see that I had the code, and this is extracted up into a more assembly code way of looking at the code, but you can quite easily identify which how to say area you get, and then you can get back to your vendor or the one who built the object code and say that, okay, we have a problem using this binaries together with our source code. So basically this is a quite a short example of how it's working. So CodeSonar for libraries increase the accuracy around library calls, and it also detect problems with libraries and IPA usage and these kind of things. So basically now we have 5 minutes left for questions. Yeah, if you have any questions, just send it in the chat window and we will answer it. We have got some questions about CodeSentry that we will not show today, but hopefully we will have a webinar of CodeSentry later on this spring. I got questions about integration to Atlassian Suite, and there is an integration with the Jira, and what you basically do is that what Mikkel showed you was how to set these annotations. And what you can do is that you can create a Jira issue or a Jira ticket from CodeSonar, either automatically when you discover some problem or manually when you go through. And another question is a question for Siemens ALM, and there is no direct integration with that tool, and I'm not sure if it's needed, but it's possible because there is an API, so you can develop your own integrations. So it's possible to do things. Another question was, I want to use static analysis in a CI environment, and what are the interfaces, and how would that get a report from each pull request being merged to a master? Yeah, there is a standard called SARIF, Static Analysis Result Interchange Format, and that is used to take results from one tool to another tool or to another environment. And CodeSonar is taking the result. So when you, for instance, if you use GitLab, you can use CodeSonar as a reviewer. So every time you make a commit, you will launch CodeSonar analysis on that code and then present the result in the GitHub format or Git. I'm not sure it was. Yeah, I think it was GitHub or. Yeah. We have not shown that today, but we will show that probably later on in April, May, when the 6.0 release of CodeSonar is introduced, because there is a lot more information or new features about continuous delivery, DevOps, and DevOps and so on. The software boom material is a feature of CodeSentry, not CodeSonar. Another question is, can you give an estimate for how many, for a million line of code, and how long it will take to analyze? What's usually, it depends very much on complexity of a switched on, I'd say, warnings or checkers. But thumb of rule is that 3 times to up to 15 times of compilation time it will CodeSonar consume for a full build. So if you have a full build of 5 minutes, it's probably take 15 minutes to or at least 15 minutes to do a CodeSonar build. But of course, for CodeSonar, you can do an incremental build. You can also have different build machines and distribute the builds on different machines. So that is a thumb of rules. And our question is, what toolkit do we have to extend the integrations? Java, C#, Python, TypeScript. Mainly, you have most of the integrations you do in Python. You can also do it in C as well, and maybe C#. I'm not sure, but Python is the most common way of doing integration in terms of integrate other tools. When it comes to doing own checkers, you can also do that in or compiler models. You can also do that in Python, but it will be faster if you write it in C language. So I think we are running out of time, and there is no more questions at the moment. So do you have anything to add, Mikael?
No, not really.
Okay. So I thank everyone for today, and you will get an email about recording, and you can contact me or Mikael or Marco or Henrik if you have questions. So I said just thank you for today, and yeah, thank you.
Thank you.